Okay, hi. Thanks for joining me. I guess this is one of the last sessions for today. My name is Erno, and I already did IoT lab here on Monday at JFocus. As a day job, I work for Oracle as a solution engineer. So look, no stickers, I'm not fooling anyone, I work for sales. But I have all these hobbies. Matthias Carlson is also a motorcycle enthusiast, so he kindly gave me an opportunity to talk about some of the side projects that I'm doing. So I'm consider myself a builder and a maker, and I think all the developers are the builders and makers of today. So I like building Legos. I did the never again experience of building our house. I like to kind of doodle with Warhammer miniatures. I even did my own Kubernetes cluster using Raspberry Pis, and kind of what it does, it clusters nicely, not much else. And you know, it's easy to make things, and I really recommend. Sometimes it would feel that, okay, the easiest thing is to make yourself a fool in front of an audience, but I recommend these conference experiences. I think everybody should come up here on stage and do the talks. It doesn't have to be that serious every time, so you should also enjoy it. First of all, I like to define hacking a little bit. So with hacking, I don't mean that you would do something illegal. I think hacking is more to come up with creative solutions to technical problems and to do knowledge acquisition. So when you start hacking things, you don't necessarily know that what it is that you need to do. You kind of gain the knowledge during the process, and you can document it. And of course, when hacking vehicles, as in this case, I recommend to be careful, because it can have, especially with those vehicles with two wheels, so if you hack any of the critical systems, it can have a negative impact on your life expectancy. So how this started is I've been a motorcyclist for 25 years. In Finland, you get your motorcycle license at the age of 16, and I've been riding all kinds of bikes ever since. What I'm working with now is Triumph Speed Triple, which I just named the Geek Triple. And look, it even has our company colors, by coincidence really. So it's a modestly modified Triumph Speed Triple 3-cylinder engine. It has this audiovisual system by Zard exhaust. And I'd really like to get a supercharger for it, but the DMV says that's very, very illegal. But besides my Triumph, I'd like to start building some other bikes, so I'm looking forward to buy this Ducati, and it's a really good benchmark for building your own kind of motorcycle projects, because it hasn't been very popular. So if you think of like the previous model, the 998, which was really iconic, that was very popular, and maybe Ducati got some ideas when Neo was riding that in the Matrix, and look, she's not wearing any helmet, so maybe she would end as dead pixels if she had crashed. But I think the Ducati engineers got their idea from the Matrix that they want to do something like science fiction, and I don't think they did that good job. But you know, this bike, it's cheap to come of it, so it's really good kind of working bench for building your own projects. This is not mine, but I'm planning to implement something similar as this one. So I was thinking that the problem with that is that these old bikes, they have a kind of cabin bag full of electronics, which were maybe cool when Nokia was the cutting edge technology. So what to do to kind of cut it down? So I started looking into how I can use the common microprocessors, the controllers that are cheaply available on the market, and hack into the bikes. So I did a project with my Triumph, and well, all the vehicles nowadays, they have millions of sensors, and you can gather all kinds of metrics from them. And most of the systems that are even nowadays used, the technology is something like 10 years old. So actually, it is pretty easy to hack into the systems and start getting the vehicle instrumentation metrics. Of course, when we look at our cars, everyone has this OBD port, and you can buy those OBD adapters to get the metrics to your phone, for example. But if you're a developer, you really don't want to use those and buy and make it easy. You want to design your own systems. But the OBD standard specifies the connector and the port, but pretty often the ports that are inside the car, they don't provide all of the data that you want to maybe use. So instead you need to tap into the CAN bus inside the car engine so that you can tap into ECU. The OBD port sometimes uses some other protocols besides CAN, for example, this K-line, which you can kind of pull for the diagnostics metrics. So it's a good starting point for creating your own applications for car instrumentation. And by looking at the connector, you can deduce that what kind of connections it has, so what ports and protocols it uses. Here are a few of the examples used nowadays which should have the connectivity. And when you wire it up, just look at the pin setup and you can start listening onto what kind of data you can get. So here are some of the examples. So the CAN bus is used with engine systems and some of the, for example, other onboard systems. And then there's this LIN bus, which is this low cost, which is usually used for the diagnostics port. And there are some more modern protocols used for that, but they are not that common. Of course, you can find them on new cars, but on the older cars, it's usually CAN bus and the LIN bus that you can tap into. So when I started to look into how I can get the details, I looked into some of the boards, and you know, as this is a hobby project, it wasn't too serious. So I kind of pick my devices like I pick my wine. So if it has a nice design, some fancy specs, and an easy interface, then you know that's the go with. But I like this PyCom board, for example, because it runs MicroPython, so it's actually multi-threaded. It has all these connectivity, so I plan to create a project where I can see where my bike goes. For example, it has the accelerometer, so when someone picks up the bike and it's not running, it starts sending the location via GPS to the cloud to see that, okay, someone is trying to move it, and uses Sigfox protocol, which is this IoT-friendly protocol by the French company Sigfox, which is really power efficient and has a long range. And once you fire the bike up, then it picks up, okay, that it's running. Then it starts to tries to connect to my phone Wi-Fi and post the data to the cloud. So it uses the low power wide area network connected for that. And well, post the data to cloud. But the PyCom isn't optimum for listening to the CAN bus, so then I did some research, and on the Make magazine I noticed that, okay, there's this Machina board by a small US company. It's completely open sourced. It's based on Arduino boards, and you can have these under the dash or under the hood versions. And like the PyCom, you can program it completely by yourself. If you're interested in this stuff, I don't have any examples here because if I would show them, I would need to connect it and flash the software on the system, and I'm a little bit shy to flash in public. But if you want to have a try with it, you can come to Oracle booth and see how you can program these microcontrollers. And I use this Machina to listen to, because it has all these automotive interfaces built into it. And I use this one to listen to the engine metrics. And when we look at the CAN bus, so usually it works that if you want to control or get any readings from it, you tell that, okay, from which address I want to get these metrics. So it's kind of polling system, but you can also listen to all of the data that is going on in the bus. So if you have these CAN hacking tools, you can tap into it and you can listen that, okay, what systems are sending which data. So for example, in your car, you can hack in or use this capture software from the CAN bus. And if you, for example, open your car window, you see that, okay, these commands are going in there, and then you can replicate them and start playing with all of the kind of devices that you can find. But again, you should have some kind of idea what you're doing, because if you miss some parts of the system, that won't maybe be covered by the insurance. Okay, so this ended up for my own bike. I get the metrics and I can post them to the cloud. But what about display? So for Arduino, we have these nice small LCD displays which we can use to build all kinds of gauges. So instead of having that huge cluster of these bulky systems, you can just build a small gauge, because in Finland the law says that we should at least log the vehicle speed, for example. So we need to have some kind of a speedometer. And that adds up the system. Few minutes more. I'm also working with some of the Finnish racing teams, because when you're racing, it's difficult to find funding for it, and of course the kind of data logging, those systems can be expensive. So I'm working with Kulju Racing. This design is a little bit old, so the bike is actually flat black at the moment, because it's much easier after, if you crash, or when you crash, it's easier to fix the bike, just paint it completely black. And I think black also matches well with my sense of humor. So with that, we are using the kind of edge and fog and cloud paradigm. So we are integrating a Raspberry Pi to act as a central node to gather the data, and so that you can see and log the data also locally, and then post into the cloud as needed. So I'm looking to, this has not yet been implemented, but we are building the bikes at the moment, and we'll see next summer how it's behaving. I hope our rider Ulla gets better. She's the women's championship winner last year for paraplegic motorcycle riding. So she's paralyzed from waist down, but she's racing motorcycles. All right, that's it. Questions, please. There's one. Yeah, she was paralyzed at age of 15 when it was a snowboarding accident. Yeah. Yeah. So I'm not actually doing via the ODP port because it's clunky, so I just cut away the ODP port and just connected it via the wires directly. So what I'm accessing is the diagnostic bus, the K line on the speed triple. I am not tapping into the CAN bus on that one. But it would be possible, yes.
Would you consider it much safer to just tap on the K line, not to mess with any settings?
Yeah, that's right, because the K line, for example, for the cars, that's protected. So in order to access the CAN and the other controller systems, you need some kind of a safety override. So only the car shops can do the safety override to access the CAN systems behind. So usually the diagnostic system it's much more safer. Okay. Okay, thank you.